So now here what happens, so it will come like this. If I click on new notebook, so if I am clicking on new notebook, so it will something like this will open for you, right? Something like this is coming for you, is it? So you want to just change to whatever you want, Rnn, so Lstm. Okay. See what language models are there. There are different ways to analyze the language models. Several approaches are there. It's up to you. Okay. So it's up to you. So now what I am doing here, you look at this. 1 minute. I will check whether I have any files related to word embedding. You need not install Jupyter also. On the cloud itself you can work whatever Python is there, that everything you can work here. So see, I'm just checking whatever it is. The sentiment analysis, the CNN I have not told lexical here. Simple Rnn implementation. So feature extraction, NLP data import techniques, time series forecasting, convolution only prediction. Okay, so many things are there. Anyhow, but all these things are not required. So now okay, so something like this is coming for you. Go to new notebook, or open a notebook or new notebook and write. It will something come like this. So you can give whatever name you want. So this name you want, whatever you want, you can. So I'll give it as Rnn bar Lstm. Okay, I have some inbuilt data. So look at this. See, there are certain things that you need to understand. So any doubts still here? All of you are able to open this Google Colab? For you, Vaishnavi is over. Shobha and Ignal, is it fine?
Yes, sir.
Okay. Okay. So now I will move on. See, I have this data, IMDb data. Okay. So IMDb means what? What is this IMDb? So I think IMDb is a platform where they'll review a lot of contents, web series, movies, drama, theater, right? So IMDb data set if you want to see. So look at this movie reviews. So this is the data set. So you have inbuilt data here. Okay. So if I go to code data card, see 66 MB big data, almost 0.5, more than 0.5 GB. So means people are giving reviews about so many things. Look at this. Somebody will say about a movie, somebody will give this much long review, critics will give so much things. So fans are there for different heroes. Where different people look at the movie in a different way, depending upon how their life is going on. Right? So anyhow, I need to analyze the things. So you have to import, say TensorFlow and Keras are some of the inbuilt libraries, modules that are present inside the Python for analysis of these deep learning models. Okay. So TensorFlow, inside the TensorFlow inbuilt data set is there. Inside that This IMDb reviews is one such data set that is already present in. I am not importing a manually static data set. I am not importing, already present inside, just like iris data set how you have. So IMDb reviews data set you already have. So I am means for analysis purpose, understanding purpose. So already we have. So what is this IMDb data set? So what is I am doing? Train test split. I am splitting the data set into train and splitting the data set into test. Train data set, test data set, comma information is equal to TFDS. Okay, total reviews then again I am splitting. So it is trying to download, and the data set is downloaded, and so look at this. So I am going to zip that into some sort of what is happening. I am downloading, preparing the data set. Unknown size, we are 80 MB. It is getting updated. I told you 66 MB. Still more than that, so much of data is there. So you have IMDb review plain text. So in the form of text. So the line code extract the sentences and labels from this data. Seems to be TensorFlow data set. It's not a normal data set. It's a TensorFlow data set. So what I am doing here, sent.np.decode UTF converts the TensorFlow tensor containing sentences to, because I have to convert everything into a number, into array. So then decodes it to from bytes to string.zip, unpacks the list of tuples into separate lists, separating sentences, everything I am detaching everything. So these are all some inbuilt functions, logics. Sent decode dot numpy dot label for sent label in train data set. So train sentences, train labels. I am separating the labels and the sentences. Okay. So because labels I am not going to worry about much, I am going to worry about the sentences. So I am separating them. So look at this. So zip is a function. So if you want to understand this, Python you have studied now. So what is this zip function is used in Python? Zip, unzip. Forgotten. See, usually you won't get a data like this. You will get in the form of a text, a CSV file only. See. Converts TensorFlow dataset. What is a tensor? Understand? In general, science, in mathematics. What is tensor? It's a structure used for storing representation and change. Tensors are fundamental data. It is a type of a data structure used by all machine learning. TensorFlow was given to Google. So if you see this, say something like this. Tensors. Here, what I can say, neural networks. See, you derive a equation of a cube, right? So x, y, z, sigma x, sigma y, sigma z. So in three directions, stress in the x direction, stress in the y direction, stress in the, we call it as a stress tensor. So we represent them in the form of a matrix. Here also in count vectorization, also here also we represent everything is going to be in the form of a matrix. So this is data is going to be, means I will tell you this, you will understand once I will what is a tensor and all, once I discuss CNN. But as of now you understand it's a mathematical terminology that we use, converts, just you understand that it converts text will be in the form of a tensor, that is how it is in the form of a tensor. It gets converted into vector, Vector is numbers, each similar words plotted on the space diagram, that is converted into array. Array is also one dimensional matrix or two dimensional array, one dimensional array. So dot decode UTF-8 converts numpy array from bits to UTF-8. This kind of strings means everything is included in UTF, standard type of string. All those converts label tensor to numpy. Everything you have to convert it into array, because everywhere the data IMDb data is in the form of a text. So if you want to see the show what is this IMDb data, because you want to see the data. Do you want to see the data? Shall we download 66 MB? Better to see, otherwise you will not get confidence. Okay. Say here, still deep learning model, I think it is running epochs. Still it is running. Let it be. I will try to download some sort of data. We will try to download. Similar, may not be the same data. Similar kind of data. 27 MB is there. We will download. Okay, it is there in the downloads. So here in the downloads, if I go here, yes, I will cut this, go to D drive, NLP, and paste it here. Right click, I will extract here. So IMDb dataset came in Excel file. So I'll just try to open this. So ChatGPT you can use, you can learn anything. SQL you can do any commands. Python you can do any commands. Java you can. But thing is that you should know when to use, how to use, where to use. First you should understand the basic things, then you can use it. Don't think that people will remember everything and develop. It's not possible for a man. Okay, just they will take the help and see comments. See, you have only this is the data. Only sentiment and same data is also there. That is only I am analyzing. This is, see, they are writing about a movie. Which movie I don't know. Several movies are there, or only one movie that I don't know. IMDb means it's worldwide. See, so many. I loved this show. I am waiting for it to come out on DVD. DVD days are gone now, right? So it's not. It mostly means it's a very old data. Correct, right? So those days were gone. Now, what is that? Huh? What? During our childhood, we used to have this DVD, CD. Maybe you people have not witnessed that. So we used to bring your friends to sit together.
We are not that.
Huh? Huh?
We are not that.
Huh?
We have seen DVD players.
You have seen DVD. Before that, DVD players, CD, VCD. So many things were there. So look at this. You have around 50,000 data. So something like, see, there is a label. These are the labels. What is this? Review is a label set. See, you have sentiment. Only one input, one output. That's all. But you have a comment. So this needs to be tokenized and count vectorized. Everything you have to do. Okay. So now what I am going to do here, similar kind of data I have here. So the sentiment analysis, I am having similar kind of. See, it is already running. I don't want to run one by one. It will take lot of time. That is why I gave run all. Anyhow, it will run. It will give the same one. Okay. See what I am doing here. I am converting them into numpy arrays. I'm converting everything, all UTF code, irrespective whatever he is going to tell. I'm going to write a symbol in different language, all commas, 0 to 1 to 3, everything is going to be there. So it is going to be converted into some sort of arrays. So for that reason I have used this code. So containing the sentences to a NumPy array. NumPy array is always, see, NumPy means it's a number, numerical pi, no text. So you should remember that. Then decodes it. See, there are different ways to do. This directly edit like this. You don't want to do like that. You know NLP techniques. What you know? TF-IDF, Bow model, bag of word model, account vectorizer, vectorization, tokenization. You know. You do whatever you want. Whatever techniques you know, you use Rnn library, convert, you play with the data, download the data first, keep it and play with the data, you do whatever you want, no problem. Directly is simply converting that to NumPy, quickly jumping to train the model. Okay. Now just yes, just complete what is that? Is converting into a number. Now what is doing? From TensorFlow.keras.preprocessing text, what is doing is importing tokenizer. Is importing. So tokens, what is tokenizer? Token is going to simply see, you have, I will tell you here. See, there is a tokenizer here. This is one more file. Okay. Just see here. So something is there here. Someone has written something. Go India, Tripura, Jitega by Jitega. So something like this, someone would have written. I don't know who has written this. So someone would have written like this. So what is this? How many words are there? 10 words are there. Okay. So now if you just want to tokenize the things, look at this, how it is coming. 9, 1, 1, 1, 3, what is this? 9, 1, 3 and all. See, first you want to count. See, first I will say, I will just execute this. Okay. I will do parallelly both so that you can understand. There we are not going in depth. Basic things. Here I will explain the basic things and I will come back. I think it got executed. Hopefully everything got executed. Yes. Yes, thank God. I think I got the result. Good. Yesterday, horrible situation. Tried in Jupyter for another batch. Lot of errors. Scratched my head for 2 hours. I was unable to get the results. So it's okay. Those things should happen. So I thought let us dump Jupyter. Try it and some solution should be there. Okay. But Jupyter also you should do. I don't have time to debug all those things. See, what is this 9? 1 minute. Tokenizer. Okay. Word.index sequences. Okay. See, tokens I want to print. 1 minute. Just I will open Anaconda. By the time it opens, see, look here. Each number will be given some value. See, for it is 9, 1 means for 1 is India. 1 refers to 1 is India is tokenized number 1. 1, 1, 1. Go is referred as 9. Wherever go is there, it will replace that with 9. Wherever India is there, it will replace that with 1. So like this, each unique tokens will be assigned certain number. Simple token, nothing else. No analysis, nothing. Just you replace tokens. Token means it's a number. So that is what that is what happening here. So at the beginning, so what is happening here? So we are trying to tokenize the things. So where after zip, everything got converted to numpy, and I am importing the tokenizer. I am fitting tokenizer dot fit on text train sentences. What is this train sentence? This is the train sentences. What is this? So where I got from this zip of. So what is this? Train comma train label and train sentences I am getting from this zip file in train data. Where is this train data? Train data is here. Train data where I am getting TFDS. Where is this TFDS? TensorFlow data sets dot load. In the TensorFlow data sets you have IMDb is one of the data sets. You have some more other data sets also. Okay, TensorFlow data sets, you get the train data, you get the test data. I'm splitting that into TF data set train and TF data set split dot test. Okay, so I am getting, so same thing tokenization I am doing. The whole depth I cannot show you because it's a 80 MB data. Okay, so that is why I just made you to understand this tokenization, how it happens. So look at this tokenization happened. So now I am adding padding. What is padding? See, here if you see Go India, that's all. But here you have 5 words. You have 5 words here. So you have, so now totally maximum number of words that can occur in a sentence is 5. But here in the first word only 2 words are there. In the first sentence only 2 words are there. So I am adding padding layers 0, 0, 0. So that to maintain the uniformity. Padding should be done to maintain the uniformity. So that is what padding is equal to. So I am from keras I am importing this padding. So that see this is going to be useful for this. Now this array looks good, right? So like this I am going to do it the same thing, no problem. So next after that what I am doing, see, look at this, I am adding embedding layer. So you see here, see I am adding embedding layer after that. So what is this embedding layer? Embedding layer means you have a neural network, so you will be adding so much intermediate layers. In that embedding layer is one such layer in a neural network. So each and embedding layers, why is, if you just see, just it's a type of hidden layers. In between the input layer, output layer, say in RNN, what is the architecture of RNN? What are the activation functions used in RNN? Activation function reloop, sigmoid, tan hyperbolic. In between hidden, see, output layer, input layer is there. In between that several hidden layers are there, right? So what happens there? What happens? In that layer I am going to add this embedding layers. So in that layer I am going to add so much of, I will show you, I think I have explained it. Okay, so let it be. So here I am adding sequential, I am adding the hidden layers. So model is equal to, model is always sequential only. RNN is a sequential model. One word, previous word, one, so one after the other, one after the sequential only. It is not a parallel processing kind of thing, it's a sequential model only. All are sequential. So adding embedded layers. So I am adding input length, output dimension 80. So what is this? So what is this? You need to understand this principle. Okay. So look at this. Size of vocabulary. 18 means what? Size of vocabulary means here you have only 2 vocabulary. Go India. So you have to decide that depending upon how much each comment will be there. See, you have written 500 words. 500 words cannot be analyzed. I'll take 50 words. First 50 words or first 100 words, something like that. Number of unique tokens that can be embedded, that a embedded layer can handle. So output dimensions of the embedding vector will be represented by two-dimensional vector. Always two-dimensional only. Output dimension or maximum we will increase length of the input C, which means so we will be having 5 tokens input length. Size of vocabulary, number of unique tokens. Unique means repeated words are not counted, it will be counted only once. So 18 unique tokens and the length of input sequence will be, here we have taken 5 only na? Yeah, how much I have taken? 5. So I have taken 5 only. Length is 5. So something like that we are adding, and we are defining the network here. We are defining the network. So shape is 5 comma 2 output shape. So embedding. So in between you have the embedding layers. So total parameters are 3. 18 into 2. 18 into 2 is how much? 36 parameters are there. What is this? Output 2. So how much unique tokens you handle? 18. So total parameters are very simple only. So it will give you output within a fraction of second. See, look here. If I see, now only it came. But in IMDb it took some time, right? Because lot of words are there. Yeah? So this model I already executed this. It's coming. So same way, now you will see here, I tokenized here. So tokenized means just like how I told you how the tokenization happens. So it got tokenized. You want to see the train sequence? I will see. If you want to see the train sequence, you can see, but you can see how it is looking. Each layer, if you want to see, you can see. See, tokenizers dot to text to sequences. What is this happening? The line fits the tokenizers on this training set to create a vocabulary index based on word frequency. So 514 unique tokens, 2000 tokens, 1800 tokens, like this it keeps on going on. The list continues. List is continuous. It is continuing. Some fellows will not comment. Just give star. They'll go. It's their wish. So like that. Okay. So like that. Next year also what I am doing? Here also I am doing the padding. Like what I did, how I did here. How I did here, the padding, whatever I have did. So where is the padding? This one, 0, 0. This is what padding I did now. So here also what we are doing some padding. So the line, look at this. This line pads, the sequence, they all have the same length. Maximum length I am considering. 100. I am not interested in reading so many things. Starting 100, whatever he wants to tell. Assumption. Again, it's an assumption. He will tell in first 100 words only. Later, he will tell in depth. Most probably, overall view of a movie is going to tell. It's not, looks like that. Specifies the maximum length of sequence. Sequences longer than 100 words are truncated. Sequence shorter than 100 words are padded. Okay, so padding specifies the padding should be added. So that is what I am doing. Okay, the same process this is I am only doing for the train data. You have tested also. One more run, one more iteration you can do it for the test data, that is not shown here. Okay, So after that, yes. So this is what tokenize and pad. This is what he has done. See, same thing. Everything put together. So this tokenizer, inside the tokenizer zip file. After that, what you did? Tokenizer to text sequence you converted. Then you padded. After padding, same. This is for the training data set. Then same thing for the test data set. Analyzed everything together. After the train labels, test labels, array. Inside the train labels, I have converted that into numpy array. Okay. So you want to see this array, you can check. So I will say I can use train labels. Okay. Odd shape or dot size. Just I will try to like this. So you see how the train label looks like. Understood the design. You see, designing a neural network is very important, and you should not rush simply copying some code, and that's good only. But understanding is very important. Then you can copy and put it. Okay. You should be in a position to answer the things. Okay, let it run. So now what happens? So similarly, I am getting the output like this. So why is using random now only? I'll try to execute this. He is passing inside the optimizer. Okay. Predicting the things. Still you are getting. Okay. See how much? 25,000 size. Test you see. Okay, I'll do one thing. Now put here. Test. Test labels what? Size. Test labels dot size. Okay. ಹಲೋ ಕ್ಲಾಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಒಂದು ಅರ್ಧ ಗಂಟೆ ಮಾಡ್ತೀನಿ ನಾನು ಹಾಂ I'll just print this 25,000. Okay. Test and size. See, now I am defining. Now we have to define what? We have to define the neural network. So what I am using? Keras.layers embedding simple RNN. Okay. So here simple RNN I am defining. See what is this? So look at this. Here I am using an embedding layer. Here also means hidden network. Embedding layers means hidden network. So here I am defining we are assuming a vocabulary size of 1000 because so much of data is there. So total you want 1 lakh, you assume more analysis. You have time. If more you do, it will take time. So it's up to you. Okay. And look at this. It's simple RNN. So this has a layer with 64 units of neurons. So 1000 vocabularies. What are neurons? 1000 vocabulary size and 64 neurons. These 1000 vocabularies are connected with the 64 neurons, interconnected with the 64 neurons. This layer will process the sequence. See, neurons will be either 32, 64, 128, 200 and 128 plus 128 is 254, 56. So in this manner, you have to, because the design of the network is like that. Neural network architecture is like that. So otherwise you have to put 8 or 16, something like that. So it depends. Okay, the neuron will process the sequence of embedded vectors. Output can be seen as a new representation of it, which carries the information of power. See here, you see activation function. I am using sigmoid. Simple Rn and sigmoid activation function can be used. ReLU also can be used. ReLU also can be used. See, what is the hidden layer? So look at this. This is what I told you, right? So W1X1. So each hidden layers are there. This is a simple RNN architecture. So in each hidden layer, you have to activate the activation function. So here I am using final output is always softmax or sigmoid. Most probably softmax. If it is only binary classification, then it is sigmoid. But here also in between output and input, so many hidden layers are there. There also, from each hidden layers are connected with neurons. From passing information from one node to another node, activation functions will be present. That needs to be activated. That is sigmoid. That is what the meaning here. So dense layers. I am using sigmoid activation. You can use other activation function as well. Okay. Fully is added for binary classification. Sigmoid activation function ensures the normal. Okay. Final is using sigmoid activation. Okay. So look at this. You will get some output here. Model. After getting the output, you want to print the results. You can print. I'll just we have got the output here. Simple RNN design. So here what we have done. Let us see here. Post padding is over. So you need to see here. Embedding size here you see. I have taken only 100. Total vocabulary size for embedding is there. I have taken 10,000 something like that. Now, so this is vocabulary size. Some more in-depth design. Here also their activation is sigmoid only. See here you see this size. There I took 64. Here I have taken 32. So embedding converts. Embedding will be having 3 inputs. One is vocabulary size. One is length. How much length I considered there? Here I think how much length I have considered. Vocabulary size 64 is the layers. Number of words is 10,000. Okay. So maximum length here I have considered first 100 words. Total number of words, different unique words are 10,000. But in a sentence, how much maximum words I am considering? 100. But here, what I am considering? I am considering max. How much it? Sorry. How much it is there? That much. How much it is there? That is the length is equal to maximum sequence. Because it's a small sentence only. Only maximum 5 words only you are having. I am considering everything. So depending upon, you should look into the data and you have to consider. So like this. Okay. So now you see maximum length, but padding is also considered. Truncating, anything above 100, it is going to truncate. For example, here you have the Excel. If it is only first 100 words are only considered. If anything other than first, see here also you can do lot of pre-processing. Remove stop words, remove 0 to 9, convert everything to lowercase, only unique tokens consider. I am not doing all those things because not required. I don't want to waste the time. That is the beauty of deep learning. You pre-process, it's well and good. If you have time, you do it. If it is not, it's okay, because the output is not going to vary that much. That is the only advantage of deep learning over machine learning. The same thing, if you want to do machine learning on a text data, you have to do a lot of circus. I told you all the NLP techniques, right? You have to take the raw data, you have to analyze, you have to remove the stop words, do the pre-processing, play with the dirty data, bring that into structured format, and then then you do count vectorization, TF-IDF, then pass on that to machine learning model. All these layers will not come, directly will pass. We will get some data from NumPy output, NumPy array. That I don't want to do here. Directly, I have confidence on my Rnn model, LSTM model I am doing. Just I will tokenize and I will do it. But here I am there, not just tokenization, vectorization, TF-IDF, bow. When you want in-depth analysis, then you will do that. Anyhow, I am not bothered about all those things. I will just pass this on to deep learning model. Okay. So look at this. That is what happening. So after this, I'll get the loss. I'll get the output. After that, what I am going to do? I have to pass this through the. When you pass a model output into an optimizer, then only what happens? Model once from now it has happened. See, where is this? This is here. You look at the things. You look at the code. Model is there. Embedding happened. It went inside the RNN network, simple RNN. It went inside the layer also. After entering, going inside the layer, inside the sigmoid output is coming out of the sigmoid activation. You got some output at the end of the RNN. Final is sigmoid activation function or softmax activation function. Output you got. One process is over. Forward propagation is over. Forward propagation is. Next, what you have to do? You have to do the backward propagation. Simply you will not do. You already have a output, actual output. Now whatever the output you have got, you got the output of during the forward propagation. You compare that model output, compare that with the actual output. So compare, you find out the loss. After finding out the loss, if you feel like you will have, so what I am doing, I am passing that inside the optimizer. In the optimizer, what happens? This backward propagation, differentiation, chain rule. Based on that, each weight gets updated sequentially in epoch. It will come back to the initial stage. In that, I am using Adam. Loss is going to be based on cross entropy. Entropy already you know. Binary cross is a binary classification, only positive or negative. That's all I want. I don't want other than that. Whether the move is a positive, so binary cross entropy. If it is a multi-classification problem, categorical cross entropy. Loss. Optimizer is Adam. You use another optimizer. No issue. We will see that also. Then accuracy. Matrix is based on. You want to change the accuracy to ROCOC, you can use ROCOC. No issue. Receiver operating characters. So it will fit the model. Epoch. Now I want to complete the epoch cycle. So how many epochs you want? 10. 10 epochs. Okay, and so test padded data. I am checking on the test data. You want to check on the trained data also, you can do, not an issue. So training I am passing, I am checking on the validation I am doing on test data, test data. So now you see here, loss is coming down each epoch. 66, 60, 61, 51, 40. Accuracy from 58 it is increasing. It got increased to 79. I want to reach to global minima. Validation loss, anyhow there is no improvement. Validation accuracy as usual. Accuracy is getting. So what does this mean? The model is trained using the fit method. Trained padded sequence is a sequence of integer encoded words which have been padded to have a consistent length. See, train labels contains binary, positive or negative. Those are the labels for each. Model is trained for 10 epochs. Validation data provides data on which the model performance is evaluated after each epoch. But it is not used for training. Okay, it is not used for training. This helps our monitor overfitting. Validation will help us to avoid overfitting. When you do, otherwise overfitting will happen. So, okay, from the logs we see that while training accuracy increases over epochs, validation accuracy doesn't show a consistent upward trend. Usually it should show. It is the validation loss is actually increasing and accuracy seems unstable. This suggests potential overfitting. So the model might be getting better on the training data but not generalizing well on the unseen. See, everywhere you have a robust model should be robust. It has to work on the unseen data also. Now tomorrow new viewers will give some other comments. That also I will pass here inside my Rnn only. For that also it should classify whether it's a positive or negative. Different ways, different people, different language skill, different writing skill, in different way they express. Each individual is unique, as his own methodology of expressing the things. But my model is unable to generalize. Looks like so much big data, it got confused. Model is too much sensitive to minor changes. So that is why potential overfitting is there. So in the updated model, several changes are made to potentially improve the performance. Especially, I want to generalize. See, equation you will develop. Y is equal to ax. What is that? Y is equal to mx plus. That's a generalized equation. That's a generalized. It means not just it's perfect equation. It's a generalized. It works well on most of the experiments. Whatever you carry out. That is the meaning. That if any two physical quantities are there that are going to have certain kind of correlation, so then that is going to fit well. Y is equal to, you can come up with new equation that is going to work, but it is not generalized. People, that is why don't accepted other equation. They accepted y is equal to mx plus c straight line equation. It generalizes well. Your model should generalize well. You are working on a company and simply if it is unable to work on the unseen data, no confidence will be there. Okay, so we want to generalize the model. People develop what is that? Mathematics, people who are doing PhD, they will develop an equation. What equation? For release of the drugs. Release of the drugs means not in the market. Inside when it is injected to human body, how it's going to interact with the cells, and for that they develop a mathematical model. It should generalize. They will develop a vaccine, drug discovery. Lot of mathematical models are involved. People do scientists scratch their head, they do so many things. And it should generalize well. Then the model, that formula will come out, how to manufacture that drug, how much quantity, how much concentration, how much proportion, how much it behaves with the so much environmental condition, then they will come up with some method. It should generalize well. It should work on 18-year-old, it should work on 40-year-old, 60-year-old, everyone. Different race, color, religion, language, food habits. Everywhere it should work. Different people living on a different climatic condition in different geographical area. Everywhere it should work. Then it's a generalized model. For everyone it is working. So now you are putting here to Indians and it is not working for Europeans. Then it's not a generalized model. You have missed something. So overfitting happens. It is understood that in deep learning or machine learning, it is validation. So new data is coming in. It is becoming sensitive. Model is so some minor modifications. So look at this, what we have done. Reduced the embedding dimension to 32. Earlier it was 64, right? 1000, 10,000. Here I think 64 now. Yeah, 10,000 comma 64. Now I am seeing overfitting means lot of things are there. I want to cut short. I want to erase. You learned so much. That is why overfitting happening. I will remove some hidden layers. For that I am going from 64 to 32. Overfitting means you have to cut short the things, remove something. So that is why we did some reduce the embedding. I added some dropout layer. Reduce the layers also, neurons also. Some layers are dropped, completely dropped. Hidden layers I will drop. Dropout layers will be there. Input layer, hidden layer, output layer. Input layer, several hidden layers, output layers. Now what I am doing? Input layer, hidden layers, dropout layer, hidden layer, dropout layer, hidden layer. It will drop out. Intermediate layers are set, some layers are dropped. So I am dropping out some quantity, 0.5, cut sizing, downsizing the. I am using regularization technique. So now I have told you about regularization in machine learning. Did I tell you? L1 regularization, L2 regularization. Did I tell? Tell me. I think I would have not told you. See.
You can explain what you told in the first class.
I told in the first class, but anyhow, I will tell you that. See, regularization means generalization. So model should get generalized. After doing machine, now you know machine learning, deep learning. That is not the end. You do cross validation also. That model should work on all the unseen data. That is generalized regularization. So we have two types of regularization technique in machine learning and deep learning. Usually several other techniques are there. L1 regularization, another one is L2. So in other words they will call as a ridge regularization. Ridge and lasso. LASSO. Ridge regularization, that is a separate topic, I will explain. Don't worry. So maybe tomorrow you just tell me. Theory is there. Theory and one simple example I will explain for machine learning. Now I am doing regularization. What is this? L2 regularization. You can do L1 also. You have chosen L2. That's all. Okay. No problem. Keras inbuilt regularizers are already there in the Keras library. I am doing the regularization. Regularization technique is adopted to reduce the overfitting problem. Okay, bias variance trade-off will be there. To reduce that only I will do regularization. So after that I will compile the model and I will pass through it. Everywhere, don't see everywhere you see Adam only they are using. You just we will check with some other optimizer now. Everywhere, because Adam is the most giving consistent performance, optimized performance Adam only gives. So accuracy. See, and also I am adding early stopping. Now is this one more concept coming here. What is this? Early stopping. So what is this early stopping? What is this early stopping? Yes, we want to reach global minima. Sometimes it will reach to global minima, it will go up. When you reach the global minima, that is The actual value and the predicted value is almost nearer. That is the maximum value that you can achieve. But if you continually keep on updating, after that it will go up again. So as soon as it reaches the global minimum, it should stop. You should stop the model. We should not, epoch should not run further. We should stop. Means till now, if it reaches the minimum cycle, early stopping. So how much patience level you want? See, first time if you observe, second time if you observe, third time it is, let us say first time it reached it to 0.1, that is the minimum. The real value is also 0.1. Or the second time also, after that it got increased. Then again second time it is coming to 0.1. Again it got increased. Third time it is coming to 0.1. You don't want to check, you will stop. If you want to check patience level 5, 6, if you give 1 means you cannot conclude. That may be local minimum, not global minimum. So patience level is 2, I have given 3. It's up to you. Okay. That's fair enough if you give 3. Right? So early stopping, so look at this, avoiding the, to not avoid the overfitting, what I have done, I did so many things, some minor modifications for my RNN ID. So now you see model.fit, train parrot, train epochs I am giving 10. You want to increase the epochs, you increase. Okay, your wish. Validation data, callbacks is equal to early stop. Callbacks is equal to early stop. And you see my loss getting reduced from 70 to 25. Validation loss, validation accuracy. So what is validation accuracy? Accuracy despite doing this, validation accuracy is increasing. Now you see, I am not just increasing at the loss, not just looking at increasing. You have to increase the valid accuracy is for the trained data. Validation accuracy is for the test data. Trained data is already input is there, or it is trained. It is going to, because already you know, you thought this is tiger, they will tell tiger. Okay, I will bring a Siberian tiger from Russia. That's not similar to same tiger, but looks like tiger only. It's so bulky, hairy, little bit bigger. That is also tiger. So it should, you should say that, baby should say that is also a tiger only. So that is validation. That's the test data. So validation accuracy. So now it is improving compared to other times in 54, 50, 70, 55, 72, maximum validation accuracy I got it. Right? So loss is minimum here. So what is this? You see the conclusion. Training loss, accuracy, continuously suggesting model is learning. Validation loss starts increasing after the fourth epoch, while the validation accuracy starts declining after the fourth epoch. You see, where is this fourth epoch? A different time, so it is stopping, early stopping. See, out of it is not continuously moving for 10 epochs. Within 10 epochs, it is stopping because I have used early stop. It has stopped at 6th epoch. After 4th epoch, you see validation loss. Validation loss was increasing. After 4th epoch, the validation loss got decreased, and validation accuracy started. Validation accuracy from here it was increasing and it got decreased. But I continued. So here what happens? Accuracy again increased, again accuracy increased. It came down and it went high. Came down, see, came down, went high, came down, went high, again went high. So patience level, I think it has bridged that patience level 3. So it will stop. This suggests the model starts overfitting after the 4th epoch. Look at this. After 4th epoch, accuracy, see, validation accuracy starts to decrease from 70% to 55%. Again it increased, that is secondary. Again it is increased, that is secondary. But if you continue keep on doing like that, it might go out of control. So we are stopping. So we stop. This prevents the model from potential overfitting, validation accuracy. So somehow we are able to increase the, not 77%, 73% only. But I have checked for 10 epochs without early stop also. Maximum 77% it will reach. So now we have avoided overfitting. We have avoided overfitting. So by reducing this from 64 to 32, each word in the weapon is now represented by 32 dimensional vectors instead of 62. What are the benefits? Fewer dimensions means fewer trainable parameters in the embedding layers, leading to simpler model, prevention of overfitting. With few parameters, there is a reduced chance of model memorizing the training, the faster training, less computational overhead due to fewer parameters. Dropout is a regularization technique. I told you, dropout is a regularization. In case 50% of the neurons are randomly turned off. Neuron will be there, you cannot remove, snatch it, but it will be made inactive. That will be made, it is not going to take any input, it will not produce any output also. So what is this? 50 are randomly turned off. This means they don't contribute to forward and backward propagation for particular batch. Okay. So benefits: regularization prevents model relying too heavily on specific neuron, promoting a more distributed approach for each neuron. In hidden layers, so many new nodes will be there. It will distribute and collaborative effort among neurons. That is what prevention of it, and it introduces noise. It will add some sort of bias. Bias means what? Noise. Noise means unwanted things. Because disturbances are bound to be there in network. Unwanted comments people, they will not comment only. Some people they are not commenting about the movie. Something they will type and they will go. Those people are also there now. If they force you to give movie review and then only they will ask you to enter the hall. What you will do? You are in no mood to analyze, judge. Or you have some problem, or you are in a rush. Such type of noise, discouraging any neurons. So that is also I am introducing. What is L2 regularization? L2 regularization adds penalty to loss function based on magnitude of weights. There is what this how it is happening. This I will tell you. What is penalty? What is weights? Mathematical technique is there. It encourages to have how weights are updated in machine learning. That I will tell. L2 regularization. Early stopping. I already told you about early stopping. Where training is halted, if validation if the validation performance doesn't improve after a specified number of epochs. In this case, patience level is, so you want to check for some more patience level, you have time, you check. So that is about RNN. This is about simple RNN. Now same thing is about LSTM. So LSTM, what happens? LSTM is having architecture is different. Long short, here you are going to update not just memory of the previous input, short term memory as well as the long term memory also. And it is RNN is sequential. LSTM, it will take the context. What happened? Okay. So what happened? Special kind of recurrent neural network are capable of learning long-term dependencies in the data. Something happened in your life, maybe your friend would have advised 2 years back. I told you not to do that. Now you see what happened. I told you 2 years back only, no? Correct or not? These things will happen in life. Should happen. Then only it is life. So then you will realize, no, whatever I said is correct. I would have taken right decision on that day. I told you not to smoke. See what happened. Correct, na? So these things are means long-term depend. This will be addressed by LST. So traditional RNNs often fail to capture such dependencies because of the problem. We have vanishing gradient, and this already told you. Theory class. Vanishing gradient and exploding gradient problem will happen in RNN. What is vanishing gradient? Weights are updated so slowly it will never reach global minimum. Exploding gradient, it will fluctuate, overfitting. Explode. You are unable to predict what happens in the next cycle. It will explode. These problems happens in RNN. RNN is not a bad model. It works well, most of the model. But obviously, you want to check the long-term dependencies. LSTMs, it will update both for movie. I don't think LSTM. Okay, no problem. They have done it. RNN is sufficient. Okay, in sentiment analysis, especially with longer text, like movie reviews, from understanding the context is crucial. So if you really want to do so, sentiment is not just based on recent but can be influenced by words that appear much earlier in the text. Here where LSTM shine. Okay, you want to analyze the context also. So look at this. Already I have told you about all this theory. LSTMs have the ability to recover or add information to the cell using structures called gates, input gates. You have forget gate. It will forget how much percentage of it you have to forget. RNN will forget everything. Context itself it will forget. LSTM portion 99% it will remember. So that is why. So bidirectional LSTMs are upgraded version of LSTM. I think here we have used the same data. 1032 layers. 32 dropout layers also I am running. Recurrent dropout 0.5. Regularization technique I am using. L2 regularization, activation function sigmoid only. In LSTM now I reloop. One is sigmoid and time hyperbolic. Here I am using bidirectional LSTM. Minor modification to all these things I cannot teach. Bidirectional LSTM, GRU is there, BERT is there, transformers are there. If I keep on teaching, I will keep on teaching. Because that much you have to understand easily. Every year new models are coming, deep learning models. But basic structure. See, you want to understand anything, LSTM and RNN is the basic foundation. Where if you know LSTM, you can build on, you can understand the architecture of bidirectional. You can understand any transformer models, deep learning model. Okay. So now you see same optimizer Adam only I am using. See this. You see any difference here? 80%. There 73, 70, maximum 77%, till 74, 75%. Here I am able to reach 80% is very good accuracy here, because you are having 80 MB of data, 1 lakh of data, that not simple data. It is comments, this much context. It is taking into the context and also taking the long-term dependencies, short-term dependencies, considering all those things, and it is giving you around 80%. It's a good model. LSTM is a good model as compared to RNN. As compared to RNN, it's a good. See, early stopping also I am using validation loss. I am monitoring the validation loss. Okay, I am not monitoring. I can monitor the accuracy also. I can monitor the loss also, and I can monitor the everything. Validation loss. Now I want to monitor the loss. Where the loss is minimum, I want to stop. Okay. So results are not satisfactory. why it is not satisfactory? See, I added something. See, why it is not satisfactory? I think I can reach some more. Maybe LSTM. If you want to monitor, see, let us see the results first. 81%. 80% I told it's good only, but this fellow is not satisfied. This fellow is me only. So I thought let us try to do some, but I didn't achieve anything whatever I wanted. 80 to 81 only. But I modified the network. What we did, so here only a little bit modification I did. What modification I did, I will show you here. That theory I will come to that later. See, 1000 activation. I used one more model, convolutional one-dimensional LSTM. This is not in your syllabus. This is, at that time I was working on convolutional one-dimensional neural network in my project when I was working in the company. There I came to know from my senior, convolutional one-dimensional LSTM models will give better results than the traditional classic LSTM model, and it will give even more value than bidirectional LSTM. I tried with convolutional one-dimensional LSTM. Okay, I thought I'll get some sort of higher accuracy, but same thing, not much, but I'm okay. I'm not that much bad. My assumption was not bad. What is this? I was able to reach a validation loss of 0.43. You see the validation loss here. See, 0.47. I'm better only, right? My assumptions are to some extent correct. And validation accuracy also 80 to 81. So not bad. Okay. So convolutional one-dimensional neural network theory, you go and study. Okay. Simple only. Not that much. You explore that thing. See, these are all theory only. Already I told you. You can study this. Okay. So now you see, validation loss I was able to reduce. I was able to get the validation accuracy of 81%. I'm successful. So convolutional 1D 32 instead of in convolutional 1D in LSTM sigmoid and tan hyperbolic. In convolutional one-dimensional neural network architecture, we use ReLU activation function. So typically a sequence of the text data, learning local patterns in data applied to the text. So see, this is the advantages. One-dimensional reduces the spatial size of representative, reducing the number of parameters and cost. This happens in one-dimensional convolutional. So I have told LSTM, bidirectional LSTM, convolutional one-dimensional LSTM also, neural network also. Convolutional 1D neural. This is out of your syllabus, but we don't teach as per the syllabus. It is just for your learning purpose. But we use in industry. Convolutional 1D is most widely used. LSTM most widely used. Two-dimensional LSTM also most widely used. But don't tell in interview I know convolutional 1D and all. You just keep it in your mind. Then if is okay, then you tell. It's okay if you tell. If you understand and tell, that's okay, not a problem. Just then they will go to next advanced model. Okay, don't do that. See, switching optimizer to RMS prop, you can see, you can check. Let us check it 1 minute. Instead of Adam, I think we have used this optimizer. If you are interested, you can check. Just replace Adam with this word. Where is this? Let us check it. I'll just run a case. Let us see later. If it is not coming well, I'll replace that with Adam. Here I have not done this stop. See, I have not used, I have not passed it through optimizer also. Not back propagation I have not done. Epoch, huh? This is epoch or what? 1 minute. Epoch, huh? Okay, epoch. So back propagation is over. Optimizers, I have not done pass. You still want to pass? Let us try. Here I will use RMS Pro. I will exit. Let us see how much there is. Okay. So that's all for today, guys. I think, can you practice in Google Colab? You will get the results. You will not find any difficulty. After getting the results in Google Colab, try in Jupyter Notebook. Okay. You will encounter error. Try to resolve the errors by yourself by looking at the YouTube. What are the dependencies, libraries that you want to install? Errors should come. You should check for errors. You should learn how to resolve those errors by yourself. Then only you will get the confidence. If you get the error first itself, you lose the confidence. For that reason, I told you to do it in Google Colab. Then you get that in Jupyter also. Do it in PyCharm. Things are like that only. Right? Yes, it's coming. I think this is. Any doubts are there? Kindly ask Ignoel, Shobha, Vaishnavi. Shobha, you were able to catch. Understood, na? Yesterday, I think I got stuck in Jupyter Notebook there. Yes. Vaishnavi, any doubts are there? Understood the logic? So I will try to see. I will try to give you one data. You do it. This is inbuilt data. Some other data is there. I will try to send you. You execute and check that also. Tomorrow, I will try to start deep learning CNN theory. After that, one project I will give. You have to do. If you do that project, you will understand all deep learning, machine learning, everything. Like that, I will give one project. So that you need not learn everything topic to topic. Do that project. So in that process, you will learn so many things. Most of the things you are like that, I will give. Okay. So that will make you to gain confidence. Okay. That's all for today. Before leaving, just I will see this output. Output is coming. Accuracy, see. This accuracy I am not interested. I am interested in this. So RMS prop also good on. Look at this. Not just Adam. Okay. But time you see. Time is 2 minutes. 80. Validation loss is 0.49. So I am looking at validation loss 0.49. Let us check if I use Adam, what is validation loss. I will run the same code again. Okay. Okay. So 0.49. After this, after getting output of this, we will stop. So when you started the class? 11. 11:10. Okay. Okay, it is coming up. I'll upload in YouTube. Anytime you can watch. You can watch any videos related to deep learning. See, these are advanced concepts. You have to go as a data engineer or a data analyst, then become, or you have to go as a junior data scientist or a machine learning engineer, something like that. Will not give you this position immediately. Not possible to handle also. They will give also. Don't go through that much stress. Complete Python you have to. See, validation loss 0.49. Here, let us see where it will stop. Added early stopping also added. See, tomorrow just remind me, I have to tell you about regularization, very important. If they ask you machine learning, then if you don't know regularization, they will say that should not happen. I will tell you L1, L2, both. I'll complete the topic first and then I'll go to CNN. It will take 40-45 minutes. And I'll give introduction to CNN tomorrow. And you give me some feedback here, I've sent you the mail. Just reply to that mail. Just the syllabus is complete. I am not running away, I will complete. It's not so that they will send me the payments. If you don't reply means it is not going to, it's not good now. What Ankush? I completed na? More than 90% of syllabus I completed. Once 90% over, we generate the emails. So that is the procedure, right? I will send you the notes also. Give me some time. I have to compile some notes. I'm compiling the things. I will give it. Okay, I think it has stopped. So it took 3 minutes. See this validation loss. Accuracy has increased. For this, I think Adam is not required. Go with RMS prop only. RMS prop also very good optimum. People are using, it's not that you have to use. So, good. But sorry, yaar. I told wrong and you people are just shaking your head. Huh? What is this? Validation loss is 0.6. What was the validation loss in Adam? 0.48, which is less. 0.48 na? Yes, that is good. There I reached 80, here 78. But this is not bad model, that is a better model. Okay. You can check with any other optimizers. RMS prop, what are the other optimizers? ADA grad, ADA delta, RMS prop. Combination of ADA grad, ADA delta is RMS prop. Then you can use Adam. What are the other? 6 to Rnn Lstm. So you can check with everything. You can check the times. Time is also important. It's consuming 3 minutes. You check everywhere how much time it takes. Then you will try to understand the. That's all for today, guys. Okay, I'll stop the recording. Any doubts are there, we will discuss tomorrow. Tomorrow, just remind me. I have to tell you about